Hello, welcome to this session. So this is Abhilash. So this is the first session on the unit 1 regression analysis. Okay, so we have started the financial decision analysis subject now. So first let's have an introduction of the regression analysis. Okay, so the regression was invented by the Carp Joss. So he's the father of regression analysis. He contributes to physics, mathematics, and astronomy. The term regression was first used in 1877 by Francis Galton. Relation analysis is the study of the uh, re- between relationship variables. It is one of the most commonly used tool for business analysis. It is easy to use and applies to many situations. Regression analysis is a set of statistical methods used for estimation of relationship between a dependent variables and one or more independent variables. Uh, it can be utilized to access the strength of the relationship between the variables and for the modeling of future relationship between the them. There are two regression types. One is a simple regression, that is single explanatory variable, and second one is the multi-regression. It includes any number of explanatory products. So regression analysis used for the single product as single product variable as well, and it can be used for multiple product as well. Dependent variables: the single variable being explained predicted by the regression model. Independent variable: the explanatory variables used to predict the dependent variable. Right? Combination coefficient B, that is value computed by the regression analysis. A tool reflecting explanatory to dependent variable relationships. Residual E, the portion of the dependent variable that is not explained by the model. The model underrun over predictions. So here you can see this is the y. Y is dependent variables is equal to coefficients. That is the B0, B1, B2. That all are the coefficients. That means that are the values computed by the regression tool reflecting explanatory to dependent variable relationships. And the X, Y are the explanatory variables. Okay, and you can see E, that is the random error term, residual, the portion of the dependent variable that is not explained by the model. Okay, so that is the residual, that is the error. Okay, so x1 2 3 xn, that all are the independent explanatory variables. B0, B1, B2 all are the coefficients, and y is a dependent variables. Regression analysis is having originally two types: linear regression, no non-linear regressions, and third one is the multilinear regression. No, I didn't add the multiple regression. Okay, so let's start with the linear. So linear means a straight line relationship between variables. That is equal to y is equal to mx plus b. Non-linear means implies curved relationships that were seen in the economics, microeconomics, when we have learned in the first sem. That time we have learned about this implies curved relationships, logarithm relationships. Cross-sectional, that is the data gathered from the same time period. Time series involve data observed over equally spaced over in time. You have all learned these four types in your first semester. The subject name was the statistics, right? That in that subject you have learned all these four types of regression analysis, and you have done mathematics too. Simple linear regression model. So simple linear regression model is based on the six fundamental assumptions. The first is the dependent and independent variables show a linear relationship between the slope and the intercept. You can see this is the slope, it is just going up horizontally. The independent variables is not random, right? The value of the residual is 0. The value of the residual error is constant across all observations. So in the linear model assumptions, in the linear model calculations, the residual is 0. It is constant. It is constant across all observations. The residual values follow the normal distributions. So only one independent variable in the simple linear, that is x. The relation between the x and y is described by the linear function, that is the slope, and change in y are assumed to be change caused by changes in x. Type of regression: the strong positive relationship, strong negative relationships, and no relationships. So you can see here the arrow, the relationship between the variables is going up from, it is going up from the bottom. That's why it is considered as a strong positive relationships. Here you can see from top it is just going down. That's why this relationship is a strong negative relationships. And this here you can see the horizontal line that is a flat line. Okay, so this is the flat line. So that's why there is no relationship between the variables. Okay, so the formula to estimate the regression model is the sample regression model and provides an estimate of the population regression line. Estimated y value is equal to estimated y value is equal to bo, that is the estimated of regression, b1x, that is the estimated of regression slope, and independent variables. So this individual random errors terms e have a means of 0. So that is the residual error. So that is constant in the linear regression regression linear model. Okay, so simple linear regression model example. So a linear estate agent wishes to examine the relation between the selling price of a home and its size measured in the square feet. So a random sample of the 10 houses is selected. So formula for calculating the dependent variables is equal to y is equal to house price in $10,000 and independent variables x in square. So dependent variables y is equal to house price and independent variables is equal to square feet. Okay. So let's see the prices. So we have a variable data. Around we have a 10 rows. House prices in 10,000. That is a y. Y is a house price and x is a square feet. Okay. So let's calculate this. So house price we can see here and square price here in the Excel sheet already added. So the output, how to calculate the regression equation is house price is equal to the price, intercept price, the coefficient, and plus the square feet. So this is how one can calculate the no, linear method. Okay, so house price is equal to the coefficient s and the square feet. Okay, so graphical representation, you can see the house price model, scatter plot, and regression line. This is the regression line which is just going up from here. You can see the below the x line is the square feet and the y line is the price, the house price. It is just going 50, 100, 150, 200. The house price, to calculating the house price, the formula is the intercept, this is the coefficient from which is just going up from 98 level, plus the slope, that means the square feet, how much square feet the house has built up. Okay, so the square feet plus the intercept is equal to the house price. This is how the house price is calculated based on the linear model assumptions. Okay, if still if anyone is just getting any queries, they can contact me personally. So we are done with the regression analysis here. Thank you, best wishes.